We're excited to share the Ann Arbor Automated Accessibility Team Inclusive Design Challenge project to address independent safety for wheelchair users in AVs. Our project demonstrates an integrated wheelchair seating station and an electric vehicle. We focused on developing wheelchair securement and occupant protection hardware that would allow people in wheelchairs to travel independently in fleet AVs. We aim to provide a similar level of safety to people using conventional seating, independent systems that can be operated without help, and accessible designs that can accommodate a wide range of wheelchair types and occupant sizes. By demonstrating feasibility of our system, we show that accessible AVs can be designed to provide cost-effective transportation options other than vehicle ownership that would increase equity by being available to people using all types of wheelchairs. A key feature of our project is our wheelchair docking station that meets Universal Docking Interface Geometry Specifications, or UDIG, which these specifications are included in voluntary wheelchair safety standards. This system allows this user to secure their own wheelchair. Attachments can be made for any type of wheelchair or scooter, and any wheelchair with compatible attachments can dock in any vehicle with compatible anchors. You can see photos of our manual and power wheelchairs with the attachments on the back of the wheelchair, which prevents ground clearance problems often found in traditional docking systems. The photo on the upper right shows the vehicle anchors, and the video shows one of our volunteers backing up to the anchor and deploying the hooks to engage the attachments. Another reason UDIG would be good for a shared service AV model is that tight tolerances and lining up aren't needed. Prototype versions of these attachments and anchors have been successfully crash tested. Our project has also prioritized developing an occupant restraint system for integrated wheelchair stations. Because of their lower mass, smaller vehicles have the potential to be in more severe crashes than large buses, so occupant protection will be important for smaller AVs. We located the wheelchair station so the person sitting in a wheelchair would be in a good position relative to the vehicle's curtain airbag. We performed modeling and volunteer testing to identify the best places to position seatbelt anchors so they provide good belt fit for a range of occupant and wheelchair sizes. Our belt system also includes two retractors that are the same type used by passengers in vehicle seats. To make seatbelt use independent as well as safe, we also developed an automated belt donning arm that locks in the floor and allows users to put on their own seatbelt as shown in this video. For this stage of the project, we installed our prototypes in a 2021 Ford Transit that was modified for electric power and wheelchair use. This demonstrated the feasibility of incorporating wheelchair anchorages in a floor with an array of batteries located beneath it, which is expected to be a feature of most AVs. The vehicle was equipped with a lift rather than a ramp because of the vehicle's higher sill height. In the vehicle, we located the wheelchair station to maximize space to maneuver while still allowing good occupant protection. Throughout our project, we gathered feedback from experts and potential users on our team made up of industrial, nonprofit, advocacy, and academic organizations. The principal investigators for the project are May Mobility and the University of Michigan Transportation Research Institute, or UMTRI, who bring expertise in AV deployment, occupant protection, and wheelchair transportation safety. We met quarterly with our wonderfully well-rounded project team partners, United Spinal, Brown Ability, the Ann Arbor Center for Independent Living, and Phoenix Mobility Rising. Our team also hosted a focus group with experienced paratransit drivers to gain insight into operational issues and feedback on the installation. In addition, we tested our vehicle with 12 volunteers. For our volunteer testing, we had 12 people who were regular wheelchair users who we picked up from their homes. Each person was in 3 trials, one each with our customized power and manual wheelchairs as well as their own. For each trial, with an example shown in the video, the person entered the vehicle, docked their wheelchair, and donned the seatbelt. They then went for a ride around the UMTRI neighborhood, and on return, we measured and photographed their posture and belt fit. They then doffed the seatbelt, undocked the wheelchair, and exited the vehicle after filled out a survey. Our analysis included belt fit, challenges using the system, duration of each task, and volunteer feedback. To close, our project has demonstrated the feasibility of installing equipment in AVs that would allow safe, independent, equitable mobility for people who travel while seated in their wheelchairs. For safety, we prioritized placement of the wheelchair station relative to the vehicle's curtain airbags and installed seatbelt anchors that prevented the common problem of the shoulder belt falling off the arm. For independence, we had successful docking of wheelchairs in all volunteer trials using UDIG-compatible hardware. Our seatbelt donning system worked, but revisions are needed to increase comfort during the process and prevent interference with armrests. For equity, we were able to install hardware in an electric vehicle with batteries below the floor, the situation expected with most AVs. As a result, a shared services AV model should be able to provide transportation to wheelchair users that is less expensive than private vehicle ownership. We thank you for your attention and appreciate any feedback.